Hello, everyone, and welcome to today's interest session. Today's topic is on the introduction to blockchain technology. I'm Dr. Mike Nizik. Interest is a program that we started years ago to introduce students at New York Tech to all kinds of different technologies they might not be fully aware of or understand, but also mostly to understand that there's a career path somewhere in these as well. So the whole purpose of providing the program, the topics, is to really introduce people to different technologies that they are existing, and this is kind of where they are. Sometimes it's free downloads for software to get going on things. So that's generally what the interest program is about. So I'm the director for New York Tech. I'm the director of the Entrepreneurship and Technology Innovation Center, or ETIC. We have centers in Harry Shore Hall on Long Island campus in room 107. And we have in room 607 in New York City, we have an ETIC as well. Through our centers, we do things like the interest program, but we also have our own robotics program called Ursula. That's our own innovative robotics program for students to design electrical, mechanical, software-driven components. And we also do outreach to high schools with that program. We have our YouTube channel, which is at NYIT ETIC is our handle for that. We have our annual hackathon coming up, which is actually March 28th. That'll be something like our 8th or 9th cybersecurity hackathon. So March 28th is the date for that. And you'll see a NASA logo there. We have our NASA contract that we prototype for NASA. We prototype for all kinds of startups here as well. So that's kind of where these programs are coming from, the center. And if you want to go check out any of those things, you can, any of those portions of ETIC. Feel free to do so using any of these links. So today, one of the technologies we wanted to cover above all of our other technologies that we introduced in this interest program, I think there were 14 sessions this year, is blockchain technology. And one of my caveats to this particular lecture that I usually put out there is we're not really talking about cryptocurrencies in the markets and what's going to go up, what's going to go down. It's not really a finance or economic driven conversation. It's more of a technology-driven conversation. We're the College of Engineering and Computing Sciences. ETIC is a prototyping center for technology. So it makes more sense for us to talk about what the technology is, how it works, why it drives cryptocurrencies, of course, and NFTs and things like that. But honestly, it's about technology and careers. That's our approach to this particular topic. I like to say that up front because sometimes people join, they think they're going to understand what the next big cryptocurrency purchases, and that's not really what we do. I'm not an economist at all. I'll give that disclaimer up front. So I'm going to talk about kind of the origins of this presentation, where it came from, some current blockchain events and interesting topics of what keeps making blockchain so really interesting to us. Blockchain is a database at its core, so I'm going to talk about a little bit about database history and why this one is so specific in its nature that it really solves a lot of different problems that we didn't really have solutions to before. And talk about crypto versus blockchain versus NFT. There's the words, no matter where you look, no matter where you read, no matter what you hear, they're just terms are thrown in all over the place that they're just not always really belong where they belong, right? So I like to clear that up and what they are. Then we'll talk about proof of work versus proof of stake a little bit. And then we'll talk about some blockchain basics. What does blockchain solve? The business and societal impacts of blockchain. And then some of the other pieces like the actual software programming tools that are used, Solidity, Rust, JavaScript, Viper, and Yule to actually create smart contracts. That's really where the career aspect is. Right? So in general, we'll have a nice presentation. We'll have a nice discussion after, and hopefully I can introduce the topic to you, answer some few questions that you didn't know before, and hopefully you might be thinking about where you can go career-wise with something like this. So for me, my blockchain journey was really very much like everyone else's, like just hearing it come out years ago and not trying to understand what the real impact was, or what the real groundbreaking kind of differences were. I ultimately wound up taking some of that work that I did to kind of learn that and wound up adding it to a chapter of textbook called The Emerald Handbook of Blockchain for Business. I also authored a book in the Future Cybersecurity Workforce of Tomorrow for Emerald, where I have a whole section of blockchain technology for cybersecurity in there as well. So, you know, I started off with a lot of people like, what is the big deal about this, you know, this technology, and what is it? Then I started learning about the rapid expansion and acceptance of it really through today, 2025. But again, you know, my core work was looking at it early on. I was really kind of, you know, really confused about the abstract nature of it, and understanding kind of, you know, again, so many terms and so many aspects of it put out there that I really didn't. I wanted to see how it all worked together, what was driving it. And then I got to the point of, you know, is it all hype? Is it just something that's out there that's, again, kind of being driven by some sort of investor, you know, interests? And in discovering kind of how it works and what it really solves, I got to the point where a lot of us get, where it's like, okay, now I get it, and wow, this is big, and you know, didn't understand it before, but now I really want to know exactly, you know, how it works, and what things it solves, right? And then, you know, kind of how can I help everyone else get to that point? And I started putting together some presentations for classes and such, and it became one of our, you know, interest programs that I give now. So things you hear all over the news, you know, this is a little bit dated. I gave this kind of last semester or maybe even last year, but again, some of these things are very, very powerful stories, right? So, you know, we have the FTX collapse with Sam Bankman-Fried, and that was all over the news. He's in jail now, but again, we heard that on the news for a long time. But the complete collapse of a cryptocurrency exchange, right, which was really boosted on all kinds of falsities and you know, again, you know, not to get too political or business wise here, right? That was a big story. That was cryptocurrency related, but of course blockchain, because that's that technology that makes crypto possible, right? And then this town in North Carolina, right? Part of cryptocurrency, part of blockchain, you're going to hear something called mining, which solves complex mathematical problems. And the more power that you have to solve those problems, the quicker you can earn one Bitcoin, or basically add it to the blockchain, which makes it possible. But there's a town, you know, in North Carolina that basically one of these mining facilities opened up, and the town essentially is closed down because there's too much noise. There's too much noise pollution. People are getting sick from it. The town's energy bill for a small town that used to have acceptable energy billing is now skyrocketing. Nobody can afford to live there because of their electric bill, because of the amount of electric the town uses. And it's this economical, environmental impact happening all over the world that, you know, cryptocurrency, specifically Bitcoin, because it still uses proof of work, is driving, right? So all these things are just amazing that we're seeing all these different you know, stories happen because of blockchain. Right, then we saw something called crypto winter, which really isn't the case anymore, but for a while it was this absolute kind of doldrum that happening in cryptocurrency. We saw a quote unquote stable coin, a type of quote unquote stable coin collapse, which was supposed to be Terra based. And then we saw this rise of NFTs, non-fungible tokens, which are not even cryptocurrency. They're just digital assets that became provable that they were unique. And we saw that rise, right? So just within a few years, all in a row, we saw all these different amazing, you know, kind of really robust things happening. And we, you know, it makes it an incredibly interesting topic to talk about. Now, we're going to talk about blockchain technology. We're not going to be talking about what the newest crypto is and what to invest in. It's not an economic discussion lecture, but we are going to be talking about how blockchain works. And from an engineering perspective, there's ways that it works. There's very black and white and very physical ways that this thing works, and that leads to jobs, right? That leads to technology jobs and engineering jobs that weren't really there before and don't really apply to any other type of technology. They're very specific. So those of you thinking of getting into a career that's engineering based, that's computer science based, but focused in crypto, if you take a look at, you know, just today, I just got getting ready for the lecture. You know, we're going to talk about smart contracts and what they are as part of this lecture. But, you know, there's a smart contract security engineer. There's a job, right, in blockchain. When you start to see during this lecture how how new a lot of this stuff is as far as blockchain in general, to see that there's an entire career path happening now is pretty cool to see, right? So that's again why I give these interest lectures, to talk about that as things grow. Okay, so one of the things that gets lost completely in translation during any kind of blockchain discussions is the fact that it's all crypto, it's all NFT, and so it's a perfect solution, right, for blockchain, right? The concept of a cryptocurrency is a perfect solution for blockchain, but blockchain is being applied in all kinds of other financial technologies and business technologies, right? Especially logistics and things like that. So when we talk in general about how it works, and we start talking about these specific technologies, start to realize, again, from this lecture's perspective, you know, the technology used to make it possible, the problems that it solved that could never be solved with the current technology that we have, and how it's going to be adapted by all kinds of non-cryptocurrency related fields, right? There's a QR code here because it's taken from a website that's a really good website. If you guys want to take a kind of screenshot of that, look it up later or even during the lecture. Just tons and tons of activity with blockchain technology, which is what this lecture is about. That has nothing to do with actual cryptocurrencies, but they're finding ways to use it in healthcare and government and media and smart contracts, right? And that's really what we want you to take out of this lecture, is that yes, NFTs and cryptocurrency is a perfect application of blockchain technology, but the blockchain technology is simply what makes cryptocurrency possible, right? A reality. Okay, so with with blockchain, I made my own mistake there, but with blockchain technology, essentially it is a database. It's just a very new type of database, very different type of database that we've never seen before. And it only has a very specific purpose. It doesn't really replace any current database technologies, but it does some things that these database applications will never be able to do the same way. So just a quick history on databases. We started off years ago with something called a flat file database, and these are your things like DBase, Parallax, FoxPro, Access. These are just files with tables and fields that held data, but they couldn't really serve itself out to thousands of users. Then we got to SQL, structured query language, which was able to send a very small bit of information to only the requested user, and it made it much more efficient. Then we got into relational database management systems, which was a physical server somewhere on your network that hosted an RDBMS system, something like Oracle or something like MySQL or something like SQL Server, Microsoft SQL Server. And those centralized database storage applications is really what we use today for any kind of application, even if it's a tier 3 application, a 3-tier application where it's web-based. But especially client server applications, we're still using that today and will be for, probably the next 100 years, in my opinion. But like the RDBMS system, the relational databases that we have are really what we use today. Now, once you start getting a relational database management system that's too big, that's too clumsy, it stops performing at the large levels, right? So what we have to have is some kind of a NoSQL database, which are like Cassandra, HBase, Mongo, CouchDB. So these databases take all the database that's in the relational database management system and it structures it, and it's in a new database that's easily searchable, easily adaptable, right? So we can do data mining very quickly on a NoSQL database, while the relational database management system starts to fail with large amounts of data and complex kind of mining, data mining type principles, right? And then we have Hadoop or HDFS systems, which are base distributed systems, which are basically the ability to query and aggregate and access databases using the distributed processing system. So we could have 150 or 200 or 1,000 machines all doing work on the database at the same time, and then merging the results at the end to kind of give us those results, right? So this is the world that we kind of are in right now. We've had to come up with all these solutions to do that. And of course, you see cloud solutions like AWS and Amazon and Azure from Microsoft, these cloud solutions that allow us to have unbelievably powerful processing abilities in the cloud, while we're only paying really a fraction of the cost it would cost us to buy the equipment and do it in our own office, right? And that's really what's made a lot of this jump in database systems and data mining and machine learning and everything else possible is because we could never afford the equipment in our own offices and keep it running and maintain it while we just log into a website and run it on their servers and we pay fractions of the cost, right? So that's really kind of where we are now. Now, when you take blockchain has a very specific purpose in relationship to these databases. These databases still keep everything very centralized. They keep everything very kind of focused and centralized on their servers, on their databases themselves, and people are just accessing it. Now you can secure that. You can use usernames and passwords. You can encrypt it. You could use complex encryption. You could use public-private key encryption. You could do a lot of things on it, but you can't distribute it the same way that a blockchain would be, right? So the blockchain database, if we want to call it that for now, the structure of it is that hundreds or thousands or hundreds of thousands of different nodes all have the same ledger of database information on them. And when one tries to authenticate or to compromise it, meaning some sort of a cyber attack or something like that, thousands of other public ledgers that know what's on the database and the database itself are all mirrored over these thousands of network components. So it's not only is it using something called SHA, secure hash algorithm, 256-bit encryption and cryptography to protect all the data in each block, but the blocks are mirrored across thousands of different public ledgers that say, look, if you change one, all public ledgers have to agree before you change that database. So none of these database solutions do that, right? So when we start saying, oh, I'm going to have a cryptocurrency on a SQL database, no, you're not, because it could be compromised, which puts the entire system at risk, which means it'll never become popular because people don't trust it, right? Blockchain is designed in a way and delivered in a way, now running for years now, where it's really super secure, right? And it's, essentially immutable, right? We can't really change it. And that one simple characteristic and attribute of blockchain made all the other things that you see blockchain be used for possible, because people say, if it's in the blockchain, it must be legitimate, right? If it's in the blockchain, I know that nobody's going to, damage it because it's in the blockchain. You can't say that about any one of these databases, right? There's a risk, a high risk of data validity issues, data damage, when you just won't have that on blockchain database, right? So those are things that blockchain does. Now, will blockchain ever be, in my opinion, any kind of a quick asset like replace SQL? No, because it's not really set up to be that, where we're keeping thousands of records in there that need to be accessed quickly for like a medical records transaction or something like that. I just, I don't really think that's going to replace the SQL database. But again, opinions are opinions. Right. So now, just to put things into perspective, right? Blockchain itself, the actual individual PCs, individual hosts, the software that actually encrypts the data, that maintains the general ledger, the public ledger, the data itself that's in each block, right? That technology is what we're really talking about today, but it makes possible all these things like cryptocurrencies and NFTs, or non-fungible tokens, right? So the blockchain technology and how it all works, how it's managed, how people code around it, whatever, to make it useful for them, for their business. That's blockchain technology, right? But it makes possible the concept of cryptocurrencies and NFTs, right? And if you see, I mean, it's, as of last March, there's 13,000 cryptocurrencies. About 8,000 or 9,000 of them are actually functional, right, running. So you have, enough people out there, enough organizations with enough money to say this is worth creating our own cryptocurrency, creating our own blockchain, our own series of hosts, our own, and that's really what's driven a lot of this, is the value of these things. It's where the Dogecoin comes from, right? So so it came from somewhere, right? It was born at some point, and it was actually really new. If you think about, like, financially wise and actually technology wise, the whole thing, everything that you see with blockchain is about 17 years old. From inception, from somebody having the idea to 9,000 cryptocurrencies is like 17 years old. Right? That's a big deal. I mean, that's, when I used to started to look at this stuff, and it was, say, I don't know, maybe 8 years or 9 years. That was crazy. But now we're at 7, so it's maturing. But still, think about it. It's not a long time to change the entire where governments have their own cryptocurrencies, and cryptocurrencies are able to be bought and sold. And it's 17 years from the time somebody had an idea. In this case, 2008 was the Nakamoto paper that really proposed the entire system. It's pretty cool, actually. You can download it. Just go to Google Scholar, googlescholar.com, and just type in Nakamoto 2008, and it'll come up. But it's like 4 or 5 pages long. It's a very simple paper, but it proposes the entire concept of blockchain. And it's based on this concept called proof of work, which was published in 1999 by Jacobson and Jules. And basically, proof of work concept was that, if somebody works hard enough and spends enough time and enough money to solve a very hard math problem, then they should be rewarded, right? So if something's added to the blockchain based on the solution of the problem, somebody spent a lot of time and effort and money to do that. So it gets added to the blockchain. It becomes part of this chain that then becomes part of this bigger thing. We're going to see it in a second. But overall, that paper talking about proof of work and the economic aspects behind it, on top of the security features of blockchain, make it very, a very valuable, value-driven network, right? So anyway, so just so you know, didn't come out of nowhere. It was actually an original thought, something called proof of work in 1999, and then Nakamoto in 2008 actually proposed the entire system and how it would work. And really, 2009, a year later, the very first Bitcoin. Don't you wish you had bought 100 of those back then? Essentially, in a very short time, we have, because of this technology, this base level technology, right, that we just saw was applicable in medical and logistics and everything else. In a very short time, this base level technology made this whole economic, change happen, right? So it's kind of incredible. Again, always very interesting, but very incredible to see how it happened. So we talk about cryptocurrency in general, right? All these things that you're mostly familiar with. Binance, Coinbase, Gemini, right? Of course, Bitcoin, and all these. I just did a screenshot of all these other, lists of cryptocurrencies. Every one of these is made possible by blockchain technology, right? Now, every one of these cryptocurrencies uses its own blockchain, right? Its own series of hosts and own general ledger, own public ledger, and everything else. But overall, they use the same premise of blockchain that was based in the 2008 paper by Nakamoto. This idea of a cryptocurrency, they're not really doing any different than the others, but they're basing it on the same proven system that keeps things secure, immutable, and distributed, right? That's the whole concept of this. Now, the same technology, blockchain technology, that makes cryptocurrencies possible at all, also makes NFTs, non-fungible tokens, popular. So this is a list. It's a bit dated in this presentation I give, but you could see how different types of assets, digital assets, hold a certain type of value, a level of value, because they're proven and supported to be the truly one-of-a-kind original, the first email of something or other, the first original Bugs Bunny drawing, or these different things that become NFTs or non-fungible tokens, because they're hosted in some sort of a blockchain system, are trusted to have this value that they truly are a one-of-a-kind digital asset. Right? So again, I bring these things up to make sure you're aware that there's value in this technology of blockchain that is mostly recognized and observable and visibly experienced in cryptocurrency and NFTs, because they're so rampantly being accepted because of the investment value. Now that we have that background and that introduction, what are we talking about when it comes down to blockchain itself, right? The attributes are, it's decentralized. It's not one database sitting on your server behind a firewall that if somebody breaks in, all your data is gone and damaged and stolen and not valuable anymore, right? That's not the case. It's decentralized over hundreds, thousands, or hundreds of thousands of different hosts. It's synchronized. When you make one small change in one particular host on that particular ledger, all the others have to agree that that is a change that needs to get made, and then it gets made to all of them at the same time, right? So that's the value of it being synchronized. it's traceable. Not only are the transactions traceable, but per node is traceable, right? So we know that if somebody's trying to attack one node or even attack 100 nodes at the same time, it doesn't matter if you have a 1,000 node network, that the 900 other nodes are not going to see that transaction being as appropriate. So it just won't take place. So us have this trust in the blockchain network, anything that's blockchain, because it's like, you know, that medical record is original. It's that car sale happened, that house sale happened, that insurance transfer happened because it's in the blockchain, right? There's no way that like somebody went and changed it on me and say, I'm the owner of this car now. It's impossible to do that, right? And you'll see how that happens more and more through the presentation and how we fix that. But again, secure, right? We use 256-bit secure hash algorithm, a one-way hash that's not able to be reverse engineered. And then we also have something called proof of work, which is that nothing will get added to the blockchain until everybody agrees that it's accurate, but also everyone agrees that somebody has done the work to be able to be permitted to add to the blockchain, right? So then we have scalability. So you can have a blockchain that a company runs to provide secure medical, information out to your clients, to have a healthcare coin, a Bitcoin that's virtually like a healthcare coin. Whatever your purposes are, the scalability, the security, the scalability of that, you can go out 1 million hosts, you can keep adding hosts to it, you can have 100 or whatever it might be, but you can scale it out very easily. It's collaborative and auditable, meaning that you can work amongst other blockchains and stuff like that, but you can actually you have a ability to really find out what happened and when with what node. You're managing all the nodes, so you can actually go in and see very easily when a block was added to the chain and when it was added to the ledger, and you can very easily see what happened and when it happened. Right, and programmable. You'll see things later on. Those programming languages I mentioned in the beginning. Those programming languages are used to create these called smart contracts that we can actually use to program a blockchain to accept data from two different parties, right? So again, forget about cryptocurrency and forget about NFTs. If we decide to say that, like, look, home transfer sales are now going to happen in the blockchain without the town of Islip, without the bank, without the whatever, everyone's going to say, well, that's crazy. Well, is it really? If two people use some sort of a system to add something to a blockchain that's trusted, how crazy is it, right? I mean, if the bank and the town eventually say, look, if it's in the blockchain, then those two people must have agreed on the details of it and must have added it in. So that type of trust is what this blockchain technology produces. So it has this potential. I don't know if it'll ever happen, but it has a potential to eliminate a lot of this middleman paperwork that happens whenever these home sales or business transfers or banking or insurance type agreements happen. It has the potential to minimize those. So what's happening? Well, what's happening on this blockchain? Basically, you have a large network, of individual computers that all house blockchain software, blockchain solutions, but that all house a general ledger that belongs to whatever solution you're trying to manage, right? So if you happen to have a logistics application that you're trying to track, positions of boxes and things like that, fine. But if you have a cryptocurrency that you're looking to do for a very, very focused type of, purpose, you're trying to create a coin that is exchangeable between collectors of something, right? So your network of devices are all running the same software and all have the same general ledger, public ledger. And what happens is somebody initiates a transaction. I want to sell my coin to someone else, or I want to give it to somebody in exchange for something that we're doing. That transaction is logged, but it doesn't get actually processed and added to the blockchain network until someone does something called proof of work, POW. So proof of work doesn't really have anything to do with the transaction itself as far as the data involved in the transaction, that this home price, this location, this Bitcoin, whatever, this cryptocurrency, this coin itself. It has to do with solving a very complex mathematical problem. It takes a long time and a lot of energy and a lot of power, actual power, like actual electricity, to basically solve. And once it does solve it, it's also competing with other miners to solve that particular mathematical problem for that block that the transaction was added to. And now, when somebody spends that work and that money to prove to solve the mathematical problem, they get to permission to add that entry to the blockchain, right? So if something's in the blockchain, somebody worked very hard and spent a lot of money to add it to the blockchain, which means that it has some validity behind it, right? So once it's added to the blockchain, because it's distributed and because it's a public ledger, that's the same on every one. If somebody tries to hack that information and change that node right here, or even on 1,000 at the same time, all the other ledgers will update all the others. It won't ever get into the blockchain unless all the ledgers agree, right? And without proof of work, you can't do that. So the system itself, which is really what Nakamoto proposed in 2008, is really a healthy system. The downfalls of it are that from an economic perspective and a environmental perspective, I should say, that town I just told you about in the beginning, that literally everyone had to move out because the noise of the mining facility was so loud, the fans and the processors and the I don't know if you've ever heard a miner, a mining device, an actual computer designated for mining abilities. It's like an NVIDIA processor, right? They're loud. I mean, they're just whiny loud noise. If you have 1,000 of those running at the same time, the power that they use and the noise that they make is unbelievable. So I encourage you to read that article. But again, there's a real environmental impact to not just AI like you're hearing all the time now, but really this cryptocurrency mining. The power it takes for these mining centers to solve one problem is just enormous. So so it's really really an interesting time, a very crazy and interesting time. So anyway, once that blockchain gets added, once there's consensus, once that block gets added to the chain, once it's in the chain, that's it. I mean, that it's immutable. It's one of the things you saw up here. It's immutable. You cannot change it, right? It's the only way that this system would work is if everybody trusted that, like, if it's in the chain, it's golden. It's guaranteed. So that's what makes the entire system, not just technology-wise, work. It's what makes it financially and economically work too. Somebody spent a lot of money to solve the math problem to get permission to add it to the blockchain. So somebody did their work to do that, right? Once it's in the blockchain, nobody can really remove it because it's decentralized, right? So now that once it got in the chain, it's supposed to be in the chain. But also once it's in the chain, it never got changed because it's part of the distributed network, right? So there's this trust that we have now that says, like, a coin is as good as $1 or $100 or $80,000 now, because it's trusted, right? Okay, so I include this portion here because this is all very abstract. Remember, I told you in the beginning of the lecture, it's a very abstract topic to talk about. It's always these terms thrown around and no one really knows how it's put together. Well, they do, but I'm just, one of the things I like to talk about is the fact that it's a very physical process. It's a very, you have hosts and miners that are all over the world that basically agree to be a host and host a public ledger and host the blockchain data on there. And then they're one of 100,000 hosts that are on the blockchain for that particular cryptocurrency. And they're spending their own energy and everything else to kind of host the data. On the same note, there's also miners that use these mining devices, take up an enormous amount of energy, very loud, generate a lot of heat. And what they do is they code, this is a sample of mining code that will look at the blockchain address, essentially, to say, to know that this is the blockchain and here's the 100,000 hosts that are on the blockchain. And here's the list of waiting transactions, right, that need to be validated. So you write code that basically looks at the next transaction, you run through the code, try to solve the mathematical problem before anybody else does. And if you do solve the problem before anybody else does, you get permission to add that to the chain. And when you add that to the chain, you get credit paid in, used to be 1 Bitcoin, but now I think it's like I don't know, an eighth of a Bitcoin or something. So you get paid a very small piece of a whole Bitcoin now to add one to the chain. If you think about that, you're spending money to add it to the chain, but now you're benefiting from the chain increasing in value because now you add one coin and now you're going to get, $17,000 for, right? You might have spent $9,000 or $10,000 in energy and time to win 1 Bitcoin, but when you did win it, it's worth $17,000. So you made $6,000 for yourself, right? That's the economy of this thing. The downfall of it is that it's generating so much heat, drawing so much power that much of our electric grid that's producing power to kind of like keep the lights on in a hospital, it's also being drawn by AI centers and also by Bitcoin miners, right? So a lot of the power that we're paying to have produced, we're not really using the same way anymore. We're using it. A lot of it is being used for these types of functions. Okay, so if we have a physical construct to host the blockchain data and the public ledger that makes blockchain work, right? And we have code that actually runs on Linux operating systems that control each of the mining pieces, right? Who wrote the blockchain software to allow all this to happen, right? And there's blockchain providers that you can download their open source code and configure that blockchain solution to run so that people download your software using this open source code to say, oh, I'm going to be a host. I'm going to download, Hyperledger, Sawtooth, or Corda, and I'm going to, whatever application you want me to run to be a host, you create that using Corda. Your blockchain, your cryptocurrency uses Corda, and then you're having people download the hosting software. And then once they start hosting, now that ledger is on their machine, that data is on their machine. Somebody's also using it to kind of attach to your network and also start mining, right? So again, there's no mystique so much in saying, oh, this is so new. It is new, but it's not so new that there's not solutions out there. But mostly when you see as many cryptocurrencies as I showed you in the beginning, they're not writing software from scratch. They're using like an infrastructure to build that out, and then they might write their own branded software to kind of allow people to host, or a toolkit to kind of do the mining on it. Okay, so you've heard me say it a bunch of times, but basically, like when we talk about the hosting of these networks and the data and everything else, the data itself is encrypted, right? So if we look at a computer network in general, and that network is using TCP/IP to communicate, the data that flows over that network is, we say the word encrypted, and we use the word cryptography for how it's encrypted, but there's different levels of encryption. The most simplest in the world is something called the Caesar shift cipher, so I use it to give the example. But essentially, when we do a Caesar shift cipher, we have something called plain text, right? We use plain text. We use some sort of an algorithm. We have a key that we use, and we turn that into ciphertext, and then we decrypt to turn it back into plain text. And in this case, the algorithm is to move the alphabet as many places to the left or right as the key tells you to. So if the key was 3 and the type of encryption used was Caesar shift cipher, this is actually used back in thousands of years ago by the Romans, right? So they call it the Caesar shift for messaging. So basically, we're saying, all right, the key is 3. Okay, it's a Caesar shift cipher, so we move the alphabet 3, and all of a sudden the message makes sense again. Well, now we're using called something called RSA. Excuse me, RSA is for regular cryptography between network machines. Sorry about that. So we use secure hash algorithm with 256-bit key, right? So the longer the key, the harder it is to decrypt. But in secure hash algorithms, it's a one-way hash. We create the hash, and then if somebody steals that hash or gets hold of it, it's impossible to decrypt. You can't reverse engineer it. It's different every time. Even one character difference in the key to the block would be unreadable. It would be a completely different hash. So when we take the block data that's in the block, that's the data that represents the transaction of two coins being exchanged, or the car sale transaction or the house sale transaction. When we whatever's in the smart contract, right, the management of it. When we take that block data that we can read and look at it and see that it's real, and we encrypt it using SHA-256, it's close to impossible within 100 or 1,000 years using the most powerful computer to decrypt that. Okay, now that's great, but now we add one more layer onto that, right? And what we do, since it's a blockchain, what we do is we store the data that represents the real data, the plain text, before it becomes ciphertext. We store the plain text of whatever the transaction is, one Bitcoin to the other, to one Bitcoin transfer to from one person to another, or whatever it might be. Every block of the chain has not only the data for the transaction, but also the data to the previous block. So if somebody goes in and tries to alter one machine on the one public ledger on the blockchain network, and it's one particular block, first of all, both blocks know what the other block was. Second of all, that block was also replicated among 1,000 or 2,000 or 100,000 machines, right? Third of all, or fourth of all, whichever one I was on, it's also encrypted. So they would have to access every machine on the network, decrypt it very quickly, make the it's impossible. It's maybe 100 years from now, but maybe with quantum computing. But right now, it's the most secure thing on the planet, right? And that's what makes it a trusted network, which means that we're able to have solutions like cryptocurrency and NFTs. It means that if somebody knows it's part of a blockchain, I can just trust that it's not been altered, it's immutable, it hasn't been, and it's also not going to be just disappear one day because there's hundreds of thousands of machines on that particular network, right? Okay, so yeah, so just this picture, just so you're aware, this is years ago, but this was like a Russian coin mining operation that I got the picture from, just somewhere online. But they're all like this. I mean, there's just thousands and thousands and thousands of these centers just working on math problems all day long, 24 hours a day, 365. And the amount of power that they draw to generate the value of one coin is really what we're looking at. That's why the coins are going up in value, not just because there's limited amounts of them and things like that, but the amount of value that goes into actually producing them, the amount of expense that goes into actually producing the Bitcoins is is representative of the amount that's spent on adding the block to the chain. Okay. And this is just another example of the blocks looking at each other and feeding each other and making it more immutable based on that. So it's just kind of a simple one. If we talk about two people trying to make an exchange of value of some level, again, selling a car, exchanging a cryptocurrency, one coin or 2 coins or 10 coins or whatever it might be, or selling a house or whatever it might be, right? So, parties A and B wish to conduct a transaction. They have public and private keys, right? So I give you a public key not to get into asymmetric encryption, but I have a public key that you encrypt everything with, and you have a public key for me that you encrypt everything with, and we can create this block encrypted. But then what we do is we broadcast it to the network, and then it's verified that it is a real transaction, but then it has to be validated, right? So the validation is the mining, right? Somebody's got to win that particular contest between all the other miners. And then once it gets validated, validated, the block on the blockchain is created. Once it's created, it's added to, the network, where once it's added, it's immutable, right? And that's what we trust, is that this 100,000 node network has my blockchain transaction in it. And somebody did get paid for validating that contract, but that transaction, but on the same note, once it's in there, I can guarantee that nobody's going to be able to change that, right? And that's kind of what we look at, whether somebody's selling Bitcoin from one person to another, or whether somebody's creating new Bitcoin, or whether somebody is putting some sort of a legal contract using smart contract design into some sort of a publicly accessible ledger. Okay, so to demystify a little bit more, Ethereum has the Selenium software language. So when you program a smart contract in Ethereum using the Selenium language, if you've taken computer science, you've done C++ or C# or Java, or any C family of language, it should look very familiar to you. You have public classes, you have methods, you have conditionals, right? So creating these smart contracts is a career path in itself. Blockchain, like there's like the normal programmer and the normal developer and the normal app developer is not going to really understand the smart contract design at all. So if you have the programming skills from your education and your career, and then you want to apply it to a very specific path, which is what interest sessions are all about. You're not looking at anything mystical. You're still doing the same type of coding, but you're doing it in a very specific manner. And you can see this is a Solidity smart contract. That kind of gives you an idea of the types of coding and layout. Okay, so what's happening out there because this technology exists and because the value of it is so more and more accepted every day now, right? Well, what you're seeing is as an example, is one example, but like Bank of America is the leading owner and creator of intellectual property for blockchain technologies, right? So they want to make sure that they patent what they're working on and buy out whatever patents are out there for new blockchain processes. Because when blockchain does become just the way banking is done or whatever, they want to have that, right? So that's a really one interesting thing that we see among thousands of things that we see going on. But overall, when you look at the areas that in banking and finance specifically, that blockchain really solves a lot of issues, capital markets, trade finance, money laundering protection, insurance, peer-to-peer transactions, supply chain management, right? We just see all these applications being used, being possible in one way or the other. And we also see a major player doing a lot of investment in protecting it. It's a very interesting kind of series of activities happening. So to sum up, what does blockchain solve, right? It solves trust issues on transactions and contracts, right? You're not dealing with middlemen basically saying, oh, you have a bank, you have a town, you have a licensing department, you have paperwork, right? You have lawyers. All that information is currently in place because it's a very material type of blockchain, right? It's not electronic, not digital. So right now it's all on paper and it's all spread across multiple agencies that can say, no, here's the deed to the house. No, here's the deed to the house. I have a copy here. And that's what makes it work today. But the high cost of transaction fees, paying that lawyer, paying that bank, paying that town, the licensing, right? There's a lot of middleman fees that would go away if there was a blockchain solution that was accepted. The need for service professionals, right? If one day blockchain solves these problems, it's going to be pretty scary because a lot of these jobs that are currently required by law to be in place to make something legal, transaction legal, still need to be there, or may not need to be there in the future, which is very scary. So no cybersecurity risks. That's a real bold statement, but that's the closest thing we've seen to no cybersecurity risks, right? That once it becomes part of a blockchain, that data is essentially immutable. It's been tried, it's been tested, it's been researched, it's been evaluated, and it's pretty darn solid. So that's where we are with that. And no data loss or damage. The way blockchain works and the replicative nature of it, it's very hard to damage any data on one or several nodes without it being repaired by the others. And finally, business and societal impacts. No more questions about ownership, no more questions about validity, no more service providers, no more transaction fees, no more fear of data loss or theft. I'm going to put these out there as this is what people are saying, right? This is what the theories are. Is it a reality? I don't really know if it'll ever be a reality because somebody would have to trust a blockchain type solution for all these high value transactions. So we just don't know. But overall, this is some of the things that are the concerns and the impacts that might come eventually from that. Okay. And with that, I will thank you for your attendance and your attention. And that's my name and email if you ever want to contact me directly. And I thank you for joining the interest session today.